Today's topic is current electricity. So electricity means what? Electricity means the movement of charge. So whenever there is a charge, let us say Q is the symbol for charge. So whenever the charge is moving, so it is moving, let us say it is moving in this direction. So now I can say the moving charge can create electricity. So in order to move the charge, I need some kind of force. So if I say the charge is moving in this direction, right? So that means there must be some kind of force acting on the charge, otherwise the charge will not move. Now the question comes, who is responsible to produce that particular force? Okay. So here the force that is responsible to create the charge to move is basically our electric field. It is called the electric field. So what is electric field? That we should know first. Then only I can say how the charge particles move. So that means before the chapter current electricity, I must discuss about the charge. Why? Because there are one segment is that whenever the charge is there, then only it should move. Okay, so first of all, I have to know what is charge. So for this part, so first part of the discussion is about the charge. Now what is charge? Charges are said to be everywhere. I cannot imagine any particular situation where there is no charge. Whatever the object is there, if the object is there, that means charge must be there. So if I say the water is coming down from this tap in this vertical direction, okay. Now once I rub the balloon and placed in front of it, I see that the water will deflect towards the balloon. That means there must be a force acting on the water particle. Okay. So once I rub the balloon and place the balloon closer to the water, so I see that the water is bending towards the balloon. That means the water is experiencing some kind of force. Similarly, when the upper plate is tried to put on the lower plate, so lower plate is offering another force which is in the upward direction, that is the repulsive nature of force. Okay. So these forces are basically coming due to the charge. Now the question is that why the force comes and what is the reason behind it. So reason behind this is that is the charge. So regarding the charge, what is the key point is that so charge are everywhere. First point I have already said that the charges are everywhere. Now charge always be associated with mass. So whenever I am saying the word mass, that means in our mind, the first question comes that mass means associated with some kind of particle. So if there is a particle, that means there must be a mass. And if there is a mass, then means there is a charge. So that means can I say the charge is nothing but a particle? So if a particle is there, that particle has some kind of charge. It may be possible that the particle cannot have any kind of charge. Why? Because the particle may be neutral. Okay. But whenever I am seeing the charge is always associated with mass. It is like the intrinsic property like mass. So I cannot imagine any particle without mass. It is called the intrinsic property. Whenever the particle is there, that means some kind of mass is associated. So it always exists along with the particle. So if I rub my hands through these small size, tiny size thermocol balls, so thermocol balls are basically sticking to my hand. So these balls are basically the particles. So these are the particles. So whenever I say particle, so particle may have some kind of charge or may not. It depends. But what we can conclude that particle has some kind of mass. So like the intrinsic property of mass, charge is also a kind of property which is like a mass. So whenever I am saying particle, the particle has some kind of mass and the charge should have also some kind of mass. So now from this point onward, the actual chapter start. The charge is what? Charge is the property associated with matter. That means the particle should have some kind of mass. So whenever I am saying the mass is there, so that means that has some kind of charge, due to which it produces and experiences electrical and magnetic. Okay. So whenever there is a charge, so it can produce, either it can produce or it can experience. What are the two factors? First parameter is the electric effect and second part is the magnetic effect. So electric effect is known to be as the electric field. So we use the symbol E with a vector notation for the electric field. And for the magnetic field, we use the notation B with a vector notation as magnetic field. So whenever there is a charge, it has some kind of mass. And because of that particular charge, either it can produce or experience two property. One is the electric field and another the magnetic. So let us say there is a charge placed at this position. So the symbol for charge we will use the Q. So Q is the notation of charge. So whenever I place a charge, so what is happening around the charge? So it will produce some kind of electric field. So whenever the charge is at rest, it can produce only the electric effect. I cannot see this, but I can feel the effect of this. Okay. So electric field. So these are basically the lines I will discuss in the later part of the class. That these are the lines, imaginary lines originating from the charge itself. Okay. So if there is a charge is placed at this position, so from this point the lines are directed away from the charge, and it will go up to infinite direction. Okay, it will go up to infinity. Okay, so that means these are basically lines drawn from the charge itself and ends at infinity. For the charge is positive charge. Okay, so if I say this is a positive charge, for this positive charge, the electric fields are originating from the charge and ends up to infinity. So it has a long range. So it is called the long range force. Why? Because the effect is up to infinite distance. Okay. So whenever the charge is at rest, so that property where I discuss about the rest condition, that is the charge particle is not moving, it is known as the electrostatics. So this part of study is known as the electrostatics. So under the electrostatics topic, I should discuss about the charge which is at rest. So the first topic. Okay. So whenever the charge is at rest, it can only produce the electric effect, that means electric field. Okay. Now one point you have to remember that electric field cannot be seen. I cannot see the electric field, but the effect of this electric field can be felt due to some experiment or some other property like that. Okay, but we cannot see that electric field is existing, but we can feel the existence of the electric. Now the second point, whenever the charge is moving, charge in motion. So initially I discussed about the charge which is at rest. Now the charge is moving. So movement means, so in this situation it can produce both electric and magnetic effect. That means now the charged particle is producing the effect of both electric field as well as the magnetic field. Okay, both are there. So under this situation, I discussed that the movement of the charged particle is such that the particle is moving with a constant speed. So V is constant. So whenever the particle is moving at a constant speed, it can produce the electric and magnetic effect. You can clearly see that this is the green dot, green dot is the charged particle. So once I move the charged particle in this direction, so you can see that the blue colored arrow, those are there initially, that has been changed. That means this blue colored arrow signifies what? The electric field. Okay, surrounding the electric charge. So whenever I am moving this charged particle, so the arrows are changing, means the magnitude of this electric field is going to change, and associated with that, again the magnetic effect is also produced. So this particular study, which deals with the movement of the charge, which can create both the electric and magnetic effect, comes under the study of magnetism. Okay, this chapter is known as the magnetism chapter. Okay, and the third one is basically the movement of the charge when it is accelerated. Okay, so second part is the movement of the charge when the charge particle is at rest. Now we discuss about the accelerated charge particle. So accelerated charge particle means what? Now the velocity is not constant. So velocity is not constant, so it is moving with some kind of acceleration. So in this situation, what is happening? So it can create both electric and magnetic. So that is similar to the test number 2. But along with that, there is additional property is the radiation of the energy. Okay. So whenever the charged particle is accelerating, so it can create the electric effect as well as the magnetic effect, and along with that, it can create the radiation of the energy. So you can clearly see this charged particle, this is the particle, it is moving to and fro movement. So to and fro movement means that direction of velocity is changing every time. So that means it has some kind of acceleration. So acceleration is there, which is not equal to 0. So whenever the particle moves with some kind of acceleration, I can clearly see that when it comes to the one extreme position and there is another extreme position, at this position something black colored packet of energy is being released. Okay. So this energy is basically the radiation. So this radiation energy. So that particular study where we discuss about the accelerated charge particle is known as the electromagnetic wave or EM chapter. Okay. So these are the 3 basic category of the entire classification. Entire chapter is named as the electromagnetism. Electromagnetism. Under electromagnetism, there are 3 subtopics. One is the electrostatics, second was the magnetism, and third one is the EM. Okay. So this is the broad classification of the electromagnetism chapter. So we are inside this first topic, that is the electrostatics first. Okay. And under that electrostatics, the current electricity chapter comes. Okay, initially you should study the force. What is the force experienced by the charged particle? What are the properties of charge? These are to be understood properly because current is nothing but the charge. So whenever I am moving the charge, and I should understand why the charge is moving. That we also understand. So in order to understand those, first of all, you have to focus on the first topic, that is electrostatics. Okay, electrostatics. So we are inside the first topic, that is electrostatics. So summary wise, so first is either the particle is at rest. So whenever the particle is at rest, so it can produce only the electric field. That is the electric field is only produced. Second category is that the particle is moving constant speed. So V is constant. So for that it produces E and V both, but no radiation of energy. And third is that V is not equals to constant. Not equals to constant. So that is time varying. So time varying means the particle moving some kind of acceleration. So in that situation, it can produce both E and V and also the radiation of the energy. So this is the basic understanding of about charge, and accordingly there are three segments of the chapter. We are inside this first topic, that is the electrostatics. Okay. So now come to the charge. Now SI unit of measurement of charge is Coulomb. Okay. Now forget about the dimensional formula. Dimensional formula is not important in your context. Now it is a scalar quantity. This scalar quantity and can be added algebraically. Let us say there are two particles. So one having a charge of, let us say, 2 coulomb, another particle having a charge of -3 coulomb. Okay. So if I say this is the body A, this is the body B, having charge of 2 coulomb and -3 coulomb, now I can say what is the total charge? Similar to 3, that is -1. So -1 coulomb is the net charge inside A and B together. So that means the addition or subtraction of the charge can be done as a simple scalar addition. Okay.
So -3 coulomb refers to more number of electrons.
More number of electrons. Okay. Now these are the some example of the charged particle. So either the charged particle may be treated as a proton or electron or alpha particle. So proton has a positive charge. What is the amount of charge inside the proton? I say +E. Okay. Electron is the negative charge. So I say it is -E. Now what is alpha particle? Alpha particle is nothing but the helium nucleus. So inside the helium atom, so there are two protons are there and two neutrons are there inside the nucleus. And in the orbit, first orbit, there are two electrons are there. Two electrons are there. So if I remove these two electrons, so I am left with this only helium nucleus. So this helium nucleus is nothing but the alpha particle. So initially the helium atom has no charge. Why? Because the two protons and two electrons are giving the net charge to be 0 neutral. Now once I remove the electron, that means that now only the nucleus part is there. So nucleus is having a positive charge. So alpha particle has a charge of +2. Okay. So from this, what you can say that charge may be either positive or negative. So there are only two variety of charge, or maybe no charge. So if the particle has no charge, that means it's called the neutron. So just neutron. Neutron is neutral particle. So for that, the charge is how much? 0 coulomb. But whenever I am saying charge of proton, I should use the symbol +E. Okay. Now what is the value of E? E is nothing but the electronic charge, that is equals to 1.6 into 10 to the -19 coulomb. Similarly, charge on electron is -E, that is -1.6 into 10 to the -19 coulomb. Okay. And electronic charge is giving a symbol of E. So E stands for what? Electronic charge. Okay. Now this charge is either treated to be the positive or negative, but this positive and negative sign were arbitrarily assigned by the Benjamin fact. Okay. So he says that the electron is assumed to be the negative charge and proton is assumed to be the positive charge. There is no significant bit inside that. Okay. So only thing is that he arbitrarily assigned one particle as positive and one particle as negative. I can also say the proton is a negative charge. The electron is also positive charge. Okay. So once I say proton is negative, then I should say the electron is positive. But convention-wise, every time I will follow this convention that electron is negative and proton is positive. Okay. So charge may be of two types, either the positive charge or it may be negative. Okay. So whenever let us say this is the atom. So initially the atom is neutral. Why? Because the number of proton is 5 and number of electron is also 5. Okay. So if I take out 2 electron from here, now the number of electron becomes 3. The proton remains same. So now when the number of electron is less than the proton, so that is for the deficiency of electron. Okay. So deficiency of electron as compared to proton. So proton remains 5, but electron remains 2. So then is for the positive charge. Similarly, if I add 2 extra electron, if I add 2 extra electron inside this, now the electron number becomes 7. So that means now it becomes excess of electron. So either the electron may be excess or maybe deficiency. So either the charge may be positive or negative. That is, in the entire process of charge, I should only consider the addition or subtraction of electron. Why? Because the positive charge that are there inside the nucleus. Okay. So inside the nucleus, those are bounded with a very strong force. So I cannot eliminate the proton from there. Okay. So in order to remove the proton, that means in order to remove the positive charge, I must break the nucleus. I must break the nucleus, which is quite difficult task. So which is easier? Easier is to remove the electron. So that's why whenever says charge is there, so transfer of charge is nothing but the transfer of electron. So whenever I transfer the electron, then only the charge will come inside. Okay. So charge may be either positive or negative. It depends on with respect to proton. Every time you have to compare with respect to proton. How many electrons are there, which is more or less, depending on that, I can say whether it is positive or negative. Now let us say there is a body, there is an object which has a net charge of -1 coulomb. -1 coulomb. That means from this number, what I can say that in this situation, the electrons are excess, number of excess electrons. Okay. So then only the electronic charge is negative -1. Now you are asked to calculate the number of excess electrons. How many electrons are there to get it -1 coulomb? Let us say there is a object. Once I add one electron, then the charge is -1.6 into 1 minus 19. Okay. If I add another electron inside that, then the charge becomes -3.2 into 10 to the 1 minus 19. Okay. If I add third electron, then the charge becomes 4.8 into 10 to the minus 19. Okay. So like this, so if I go on adding the electron, let us say I am adding n number of electrons. So n into E should be equals to 1 then. Why 1? Because I have to get 1 coulomb of negative charge. So I am adding n number of electrons. So what is the n number? N becomes 1 upon E. Now 1 upon E means 1 by 1.6 into the minus 19. If I simplify this number comes to as 6.25 into 10 to the power 8. Okay. So this many number of electron you have to add. So that the charge on the body becomes -1 coulomb. Similarly, if I take out this many number of electrons from the body, then the charge becomes +1 coulomb. So by seeing this number, what you can conclude that this number is quite very large. Okay, now the question comes whether I have that many number of electrons inside that or not. So whenever I am saying that electron has to be added or that has to be subtracted, only I am considering the electron which are valence. So what is valence electron? So valence electron means the electrons which are orbiting in the last orbit. Okay, let us say I am considering the one sodium atom. So for sodium atom, electron configuration is 2, 8,1. So this 1 is the valence electron. Okay, if I consider 23 grams of sodium, so in 23 grams of sodium, that is 1 mole. 1 mole of sodium. So 1 mole of sodium consists of how many number of atoms? Avogadro number of atoms, Na number of atoms. So Na value is 6.023 in 10 to the power 23. So this many number of atoms are there of sodium in 23 grams of sodium. So this many number of atoms means one atom consists of only one valence electron. That means this many number of atoms means 6.023 in 10 to the power 23 number of valence electron. So that means this number is more than this B option. It is greater than the 6.25. That means I have this much amount of electron. So I can add this much amount of electron or subtract. But since sodium is a metal, so I can only take out this electron. So it is deficiency of electron. That means it becomes positive charge +1 coulomb. Okay. But the question is that how to add this many number of electron or how to take out this many number of electron. So what you can understand that whenever I have to add some electron or if I have to take some amount of electron, that means some amount of energy has to transfer. Electron will not automatically go inside the atom. Okay. So in order to take out the electron, I have to give some kind of energy on those electrons so that it will be released out from the valence electron. Similarly, you have to add some kind of energy to the electron so that it should go inside the orbit. Okay. So whenever I am saying the transfer of electron, that means it ensures that some amount of energy transfer has to be there. So corresponding to this many number of electrons, so large energy transfer is required. Large energy transfer. Okay. That means what I can finally conclude that, so there is a requirement of energy and that requirement of energy is very large if I go for a very high amount of charge. So minus 1 coulomb, plus 1 coulomb or minus 2 coulomb, these are very, very high amount of charge. Why? Because in order to get that much amount of charge, you have to transfer lot of electrons. And in order to transfer those lot of electrons, you have to give a large quantity of energy. Okay. That means in reality, the number minus 1 coulomb or plus 1 coulomb or plus 2 coulomb may not exist. Okay. On a charged particle, these charges are quite large. So in reality, that charge should be very small, not so high. So what is smaller value of charge? So coulomb is the unit of the charge. So if I go for the smaller quantity, then I should go for millicoulomb or microcoulomb or nanocoulomb or picocoulomb. So these are the different lower quantity of charge. Milli means 10 to the power minus 3, micro means 10 to the power minus 6, nano means 10 to the power minus 9, pico means 10 to the power minus 2. So these are physical charges. But 1 coulomb, 2 coulomb, these are the quite large. Why? In terms of the energy transfer. Okay. So let us say the body has a 10 to the power minus 12 coulomb charge. So this number is positive charge. So once I say this is the positive charge, that means
Sir, I can't hear you.
you can't hear me.
Sir, can you repeat what you said?
So a body has a charge of 10 to the power minus 12 coulomb.
Yes.
Okay. So that means it is a positive charge. So positive charge means the deficiency of electron. So deficiency of electron. So excess, these two options are not correct. Okay. So I should go for deficiency of electron. Now, in the earlier example, what we understand that if a body has a 1 coulomb of charge, that means it should need 6.25 into 10 to the power 18 number of electron transfer. Okay. So in order to transfer in a minus 12 coulomb of charge, so I need 6.25 into 10 to the power 18 into 10 to the power minus 12. That means 6.25 into 10 to the power 6. Okay, so this many number of excess number of electron. So the efficiency of electron. Why? Because it is a positive charge. So option C is the correct one. 6.25 10 to the power 6. And that is quite acceptable number. Okay. Why? Because this charge is very small. We call the picocoulomb charge. Picocoulomb 10 to the power minus 12 coulomb charge is the picocoulomb charge. So these small quantity charge can exist inside our body. But whenever I am saying 1 coulomb, 2 coulomb, 3 coulomb, 4 coulomb, these are quite unacceptable charges. But in numerical, the body may have any kind of charge. But in actual reality, you cannot transfer that much high amount of charge in a body. Okay. Now the properties of charge. So far we understand that there are two types of charges. Either it may be positive or it may be negative. So first property is the attraction or repulsion of charge. Okay, so whenever the charges are like charges, so if the charges are both positive or both negative, so they will repel each other. If the charges are unlike charges, they will attract each other. Let us say there are two charges, and I am saying this is a charge Q1 and this is a charge Q2. Okay, so both of these two charges are of same nature. Why? Because they are negative. So if I say on Q1 the repulsive force acting is F, so on Q2 the same repulsive force acts is F. That means the magnitude of these two forces should be same. If I say this is a positive charge Q1, this is a positive charge Q2, then also the repulsive force acts. So this is force A, this is also force A. If I say this is a Q1 charge, this is negative charge, and Q2 is positive, now the force becomes attractive. So here the force is F. So what we understand from this is that if the charges are like in nature, then the force of attraction, force is repulsive force. And whenever the unlike charges are there, then the force is attraction. But whatever is the force on one particle, the magnitude of the force should be same on the other particle, first of all. And the direction is opposite. Now, if I say this is the positive force, why? Because this is a positive x direction. This is the x direction positive. So if I say this is a positive force, then this force should be negative. Why? Because it is acting in the opposite direction. Similarly, if it is positive, so this is negative. If I say this is positive, then that should be negative. So
Yes.
every time, if one force is assumed to be positive one, the other force should be negative one. Okay. So this is the first property. So how to identify whether the attraction and repulsion exists? So that basically performed using some kind of experiment. So if I take two different ball having the same charge, nature of charge is same. If I place side by side, then they will be repelled back. Okay, they will be repelled back. And we measure the angle of repel. So how much angle is created with the vertical from the experiment. And if I say repeat the same experiment with the positive charge, then also they will repel, and this angle can be measured again. Okay. So if I increase the amount of charge, let us say is initially 2 Coulomb charge, with a negative, and we found this alpha angle, let us say 30 degree. If I increase this charge from minus 2 Coulomb to let us say minus 6 Coulomb, okay, so then this alpha angle should also increase. Let us say it becomes 60 degree. So through different set of experiments what we perform, we know that if I repeat the experiment, and ultimately you can say that if I increase the amount of charge, then the angle of deviation is also more. But once the charge are zero, neutral charges, so they remain flat. So there is no bending, there is no deviation. But if I repeat the same process, if one charge is positive and another charge is negative, so then they will attract towards each other. So alpha will be in the opposite direction. Alpha will be in the opposite direction. So it concludes that unlike charge will attract and like charge will repel the experiment. Okay, initially people don't know this. Once we do the experiment, then only we understand that this is happening. Okay. Now come to the second property. Second property is the most important property of the charge, because the conservation of charge. Okay. So charge is neither created nor destroyed. That means whatever the charge is there during the creation of the universe, it still remains same. So I am not going to change the charge. What I can do, I can convert one charge to the other charge. Okay. So in every reaction or transformation, so reaction means in terms of chemical reaction. Whenever there is a chemical reaction is going on, so there may be charge transfer. Why? Because there is a oxidation reduction reaction. So in a transformation also, the total charge on an isolated system remains constant. Okay. Now what is that? So let us say I am doing one experiment. I am taking one rod. Inside this rod, there is a plus 4e charge, and there is a ball which is at no net charge 0. So initially Qy is what? Qy is initial charge is 4e. Okay. Now once I touch this rod, so let us say some 2 electrons will neutralize this proton. Okay, so ultimately what happens? The charge on the rod is plus 2, and since 2 electrons come out from this ball, so that means the deficiency of electron means here also become plus 2e charge. So what is the total charge final? 2 plus 2 means 4e. So total charge after the transformation and before the transformation remains same, provided it is kept inside the isolated system. What is isolated system? Isolated system means that throughout this situation, so it may be possible that the outside there is some 6e charges there. So no matter this charge can go inside. Okay. Or during the transfer of charge, so I cannot say that some amount of charge from here will come out. So that is not also possible. Okay, that means no charge can cross this. This is called boundary. Okay. So whenever I make an isolated system, I can conclude that no amount of charge can cross the boundary. Okay, so boundary is the section where the charge is not crossing. So if the charge is not crossing, that means I can conclude that this is an isolated system. And for isolated system only, total charge remains. Whatever the charge that is there initially, that remains in the same situation. Let us say there is a isolated system. Inside that, let us say there are 3 particles. So there is A, this B, and this. Okay, A, B, and C. So initially, let us say A has a charge of 4 Coulomb, B has a charge of minus 3 Coulomb, and C has a charge of, let us say, 2 Coulomb. Okay. So once they are getting connected with each other, ultimately some kind of charge transfer takes place. So let us say 4 Coulomb becomes 2 Coulomb, minus 3 Coulomb becomes minus 2 Coulomb. Now you are asked to calculate what is the final charge on the B body. So what is the initial charge? Initial charge is 4 minus 3 plus 2. So 4 minus 3 plus 2 is the initial charge. That is nothing but the Same charge that should be in the final state. The final state is 2 minus 2 plus x. X is the charge inside this body, inside the cell. So ultimately 4 plus 2 is 6. 6 minus 3 is 3. That should be equals to x. Okay. So that means what you can consider that for this isolated system only, the total charge that was initially there, that remains same in the final state also. Okay. So this is the conservation of charge. Now the third is called the relativistic invariant. What is that? So if I consider the mass of a particle, so mass of a particle varies with speed. So m is given as the expression of that m naught divided by under root of 1 minus v square by t square. What is v? V is the velocity with which the particle is moving, and c is the speed of light. So if say that v is 0, v is 0. So that means m is what? M is nothing but m naught. So that m naught is called the rest mass. So whenever the particle is at rest, what is the mass? That mass is m. Now let us say the particle is moving. Let us say the particle is moving v, that is equals to 10 meter per second. Okay. If the particle is moving 10 meter per second, then what is the mass? M should be equals to m naught divided by under root of 1 minus 10 divided by 3 into 10 to the power 8. That is the speed of light whole square. Okay. Now in that situation, what I am saying that the v number is much less than c. Now v number is much less than c because v is 10 meter per second and velocity of light is 3 into 10 to the power 8, which is much greater. So if v is much less than c, can I say that 1 upon v square by c square, that number is almost negligible. That means v square by c square number is tending to 0. Okay. That means what you can say, m is nothing but approximately equals to m. That means whenever the particle is moving with a very low speed, okay, then I can say, if we say the mass is not changing. But if the same particle is moving with a very high speed, let us say now the velocity is c by 2, half of the light speed. Okay. Now I cannot neglect v square by c square. So now what is the m? M becomes m naught divided by under root 1 minus v by c means 1 by 4. Nah, that means m naught divided by root of 3 by 4. That means it becomes 2 m naught by root 3, which is greater than m naught. Okay. That means whenever the particle is moving with a very high speed, the mass is going to be changed. That means mass is going to increase. Okay. Now in this situation, if I go for a particle, hypothetical particle, let us say the particle is moving with a velocity which is almost equals to c. That means in that situation, v square by c square number is tending to 1. Okay. That means then derivative becomes 0. That means m tending to infinity. That means if I say one particle is moving very close to the speed of light, then the particle becomes infinitely large or mass becomes infinitely high. Okay. So which is impractical, which is not possible. That means any particle I cannot be moved with a very high speed, close to light. Okay. So that means the mass of a particle varies with the speed, and this property is known as the relativistic variant. Yeah, relativistic variant. That means it is varies. That's why it is called variant. Okay. But charge is not variant. Why? Because if the charge is at rest or the charge is in moving condition, in both the situations, charge is not changing. Okay, but mass is changing. But whatever the charge that is there, if there is in a particle, the 2 Coulomb charge is there. If the 2 Coulomb particle is at rest, then also it remains 2 Coulomb. If the 2 Coulomb is moving with a very high speed also, then also the charge is not going to be changed. It remains same. That's why it is called the relativistic invariant. Okay, it not varies.
Yes.
Fourth property, charge can be quantized. Quantization of charge. The charge on a body must always exist as an integral multiple of fundamental unit of charge. What is the fundamental unit? E. Okay. So if I say this is the E charge, then it is, let us say 2E charge, let us say 3E charge, 4E charge, 5E charge, like this way. All the charges are increased by 1 unit, that means the electronic charge is multiplied by integer number. Okay. So if I say the charge is over here and I am saying the charge is 2.37, which is not possible. That means it is a fractional value of electronic charge, which is not possible. Okay. So always the charge on a body, if I say Q is the charge on a body, that should be equal to N into E. What is N? N is the integer multiple of electronic charge. Okay. So every time that N number should be integer, N cannot be a fraction number. N cannot be a fraction. But that is a concept that that means if electron is there, let us say, so I can divide the electron into two components. Let us say I divide it into two parts, and I say one part is E by 2, another part is E by 2. That is true. I can divide. So if I divide, then the fundamental unit of charge is not E. Can I say E by 2 is another fundamental? If I divide the same electron into three parts, then it becomes E by 3, E by 3, E by 3. So multiple of submultiple of E charge also exist. These are known as the quark. These are known as the quark. But this quark concept is not important in our physics. Quark concept is not important in our physics, so we don't consider this effect. We only consider the charge on a body cannot be divisible. That means E cannot be further divided. So E is the only number, and what I can get the value of charge, which is always integer multiple of that number. N is always integer. The concept of quark is not important in all context. Okay. So minimum magnitude of charge, that is called the quantum of charge. Okay, that is basically E number. Okay, an object can have, if measured in Coulomb, that is 1.6 into 1 minus 9. I cannot divide. I cannot divide the electron, so always the electron have to be inside the fundamental quantity. And if it is fundamental, that means it is always, charge is always integer multiple of electron. So this is basically the difference between the charge and mass. Okay, so whatever we learned is summarized in this way, that electric charge can be either positive or negative. The charge is either positive or negative. But mass of a body is always positive. Mass can never be negative. Okay? The charge is conserved. The charge is conserved. So conservation of charge. Mass is not conserved. Why? Because mass can be converted into form of energy and vice versa. Okay. So E equals to mc square is a well-known equation by Einstein, which says that the electron charge or mass can be converted into its equivalent form of energy. Only conservation of mass is not there. Okay. Charge can be quantized. I have said the charge can be quantized, but quantization of mass is yet to be established. Okay, that means I cannot say that this is the minimum possible mass that you can measure. Okay, but I can say the minimum value of charge that I can measure is the E number. Okay, still the quantization of charge, mass is not established. Charge is relativistic invariant, but mass is relativistic variant. Mass is variant. Force between the charges may be attractive, may be repulsive. There are two possibilities, but force between the masses is always attractive, and this force is the gravitational force.
Yes.
This force is the gravitational force. So gravitational force is always attractive in nature. It can never be repulsive in nature. So this is the basic difference between the charge and the mass. Okay. Now, so which statement according to the following is wrong in terms of electrostatics? So electrostatic statement wise, the stationary charge can produce both electric and magnetic field. This is the incorrect statement. Why? Because stationary charge can only produce electric field. Okay. Now come to the concept of force. Before that, so another segment I have not discussed over here. So what is so far what we consider that the charge are of two types, either positive or negative. Now the question comes, how the charge can be obtained on a particular body. Okay, now how the charge can be obtained on a particular body. So there are three methods to get the charge. Let us say there is one body A and there is another body B. Okay, so there is one body A, another body B, and so there are two different material. Okay, there are two different material. So let us say I say the electronegativity of A is greater than the electronegativity of B. What is the meaning of that? Meaning is that A can attract or A can take more electron rather than B. Okay, electronegativity value is the amount of electron that can be added to any material. Okay, so A has the affinity of electron is more rather than B. So once I rub B over A, so electrons from B will go inside this A body. Okay, so ultimately what happens? A becomes negatively charged and B becomes positively charged. Why? Because from B, electrons are transferred into the A body. So this process of charging is called the rubbing. So once I rub one body over other, so depending on the electronegativity difference, one body becomes positive, another body becomes negative. Okay, so this is the first method of charge. Second method of charging is called the conduction. So let us say there are two bodies. This is A body and there is B body. Okay. So let us say B is neutral. B is neutral.
Yes.
And A is, let us say, having a positive charge. A having a positive charge. So once I make a contact between them, once you touch them, once I touch them, so charge from A body will go inside the B. Okay. So ultimately, after some point of time, what we observe that the charge on A body is reduced and charge on B body, which was initially neutral, is increased. So ultimately, what happens? Both bodies will gain some kind of charge. Okay. So if I say the both the bodies are symmetrical, symmetrical means made of same material and dimension wise they are equal. The radius, all those parameters of geometrical dimensions are equal. Then if I say the body A having a charge of Q initially and body B having a charge of 0 initially, so after I make a contact, so half of the charge, so Q becomes Q by 2 and 0 becomes Q by 2. Okay. So what happens? The charge will transfer from this point to A charge to B. So during this mechanism, so I have to make the contact between A and B, and because of that only the charge from one body go to the other body. That's called the conduction. This method of charging is called the conduction. Conduction. So this is the second method. And third method is called the induction. So in induction, what happens? So let us say the A body and the B body. Okay. Initially B is neutral, so Q is 0. Let us say A body having a positive charge. A body having a positive charge. So you are making A and B very, very close to each other, but you are not making the contact between A and B. So the distance of separation between them is very small. Small separation. A small separation. So during the small separation, what happens? The positive charge that is there inside A, which will try to repel the positive charge that is present inside the B. So all the positive charge on the body B will be go on the outer surface like this. And the negative charge will be attracted towards A body. Okay. So positive charge A, when placed in front of B, so then the charge on the B body will be distributed. But still the net charge on the B body is 0. Whatever the positive charge is there, that is the same charge is negative. Now if I connect the B body with the R, now I take a wire and we connect with earth. So there is a symbol of earth. So earth is a huge source of electrons. So once I connect this earth wire, so then the electron from this earth will go upward. Why? Because earth is electron source. So large quantity of electrons are stored inside the earth. So from the earth, gradually the electrons will come inside the body B, and ultimately all those positive charge will be neutralized. Okay. So ultimately what happens, the B body has, now once the positive charge is neutralized, so we disconnect this wire and we take out the simple body B. So once I get the B body, now whatever the charge that was there initially on the left side, that becomes distributed throughout it. So body B becomes negative. Okay. So this is called the induction. So with the induction, I am getting the opposite charge. Okay. So whenever the positive charge coming in close proximity with the neutral charge, then on the neutral charge, the charge becomes negative. In conduction, same nature of charge comes, and in rubbing also the opposite charge comes. So these are the three different ways by which I can get charge inside it. Okay. So with the basic understanding of charge, property of charge, and how the charge can come, now we go inside the second part of the topic.
In conduction.
Yes.
In conduction, both the bodies will have the same charge.
Both the nature of charge. If A has a negative charge, then B also should have the negative charge. If A is initially positive charge, B is also positive charge. Okay. So same nature of charge will be transferred. Same nature of charge will be transferred. Okay. And what I conclude that if the bodies are of same dimension, then the charge will be distributed evenly. Charge is distributed. Okay. So with this basic understanding, so now we know that there are two types of charges, and I also know that how the charge can come inside. Okay. Initially, all the first statement is very, very crucial, that charges are everywhere. I cannot imagine any object which is not of charge. Why? Because whenever I am seeing object, that is inside the object, atoms are there, and inside the atoms, the electrons are there, protons are there, neutrons are there. That is all are charged particles. Okay. So whether I am getting the positive charge or the negative charge on the body, that depends whether I am performing the rubbing operation or conduction or induction. Okay. But initially all the bodies have some kind of charge. Okay. Initially all the bodies have some kind of charge. That's why it's called the charge is a radius. Now with this understanding, now come to the concept of Coulombs. Okay. Because I am going inside the that particular quantity which is responsible to move the charge, that is a force. Okay. So first we discuss about the force. So who is the invented that particular force? That is Coulomb. So Coulomb was a physicist. Okay, Coulomb was a physicist. He began his career as a military engineer in the West Indies. So later part of his life, he found his job is not suitable. He come to the Paris and he start to do some kind of scientific research by his own. Okay, and he invented a balance, torsion balance. Okay, these are setup, simple setup that he invented. Now, the animation is shown over here. Try to see the animation clearly, but I am drawing it parallel. Let us say there is a one rod connected to two different balls. So let us say I am drawing with the white ball. Okay, and there is another ball. Let us say yellow colored. Okay, connected with the rod. Now this rod is fixed. This rod is fixed. Okay, this rod is fixed. You can clearly see this is the yellow rod. Okay, with that is the fixed rod. Now there is another ball. Third ball is there. Let us say I am drawing with the blue color. Now this is the third. So this is the third ball. Now once the third ball is coming down, it will touch both the ball. Okay. So blue ball is in contact with the white as well as the yellow colored ball. So let us say in the blue ball, let us say I put a charge of plus Q. Okay, if I take plus Q charge in the blue ball, so once they make a contact between them, so now the conduction will happen. So because of conduction, each body will get the equal charge because if I say all the balls are of equal dimension. Okay, so ultimately this white ball will get the charge of Q by 3. Yellow ball will get the charge of Q by 3 and blue ball is also getting the charge of Q by 3. So once I touch this with the blue colored ball, now we release the system. Okay. Now what you observe that the yellow colored ball is fixed, it cannot move. But what you can observe, the white colored ball will move in this direction. It will rotate. Okay. It will rotate. So this rotation is known as the torsion. This effect is known as the torsion. So he performed this experiment several times. So let us say first experiment he has done and he found that the angle by which this blue colored white colored ball moved, let us say by 10 degree. Okay. Now once I increase this charge, let us say in the second set I am getting this charge is not Q, let us say I am getting 3Q charge. So once I get the 3Q charge in the blue ball, now the more amount of charge will come on the yellow and the white. So more amount of deflection. So gradually what I perform that several times I repeat the experiment and what I observe that the angle of deflection is moving. So there is a protector from where I can measure that how much angle of deviation takes place. Okay. So that angle, let us say first angle got at 10 degrees, then at 20 degrees. Like this, so I can go on increasing the angle by increasing more number of charge, more amount of charge. So we perform the several set of experiment and ultimately conclude that the angle by which it will deflect, it depends on the amount of charge present in the blue ball. Okay. Once I make the contact, then the blue ball is distributing the charge to the white and the yellow, and ultimately the entire system is rotating. Okay. So this is the setup of experiment he performed, and parallelly he does another set of experiment where he
These balls, they are the same charge, the same amount of charge, the same
yes, repulsion takes place. Okay, repulsion. If I say that blue color ball is negatively charged, then also using the conduction, equal charge, nature of charge will be same in the blue, white and the yellow. Okay. So parallelly, along with the torsional experiment, Coulomb also does some kind of experiment based on this setup. What he does basically, so there are two balls. There are two balls. One ball is hanging, another ball is moving towards this hanging ball. Okay. Now again the charge on both the balls are same. Okay. Now as the distance between them are closer to each other, so back in the back. So there is a scale. So with that scale, what you can measure the distance of separation between these two balls. So once I make this ball closer to this, I observe that this ball is moving further away. Okay. So how much distance of separation between them? Depending on that, the how much is the deflection of the second ball. Okay. So again, he do a lot of set of experiment and ultimately conclude that again also the force is dependent on the separation between them. Okay. So if I say this is the R separation value, so R depending on the value of separation, what you can conclude the deflection of the second charge. And here the deflection is dependent on the charge magnitude. Okay. So first setup, torsion setup, where the deflection, whatever the deflection I am getting, is dependent on the value of Q. Okay. In the second setup, he performed the same experiment, but he observed that here the deflection is dependent on the R value. Okay. If the separation is closer, that means more amount of charge. If the separation is less, that means less amount of charge. Like this way, he go on repeating the experiment and finally conclude the law is known as the inverse square law. Yeah, this is known as the Coulomb's law. Okay. The law quantifies the amount of force between the two stationary and electrically charged particles. The stationary means these two particles are at rest. So Q1 and Q2, these particles are rest. They are rest particle. And on the particle, so these are particle means these have some kind of mass. Okay, these have some kind of mass. Whether the particle is there, that means there is some kind of mass. So regarding the mass, he concludes that this mass must be point mass. What is the point mass? Point mass means it should not have any kind of dimension. Okay. So for a point mass particle, and if the particles are at rest, then only this law is valid, and this law is known as the inverse square law. Now, what is the statement of the law? So, according to the law, the magnitude of this force, electrostatic force, acting between the 2-point charge is directly proportional to the product of charge. Let us say one charge is Q1, another charge is Q2. So, this force is proportional to product of the charge Q1 and Q2. And this is the first statement, and inversely proportional to the square of the distance between them. So if R is the distance between them, the second you perform that it is inversely proportional to R square. So this is the basic of the two law, and that's why it's called the inverse square law. Why? Because R square comes from the denominator. So combination of these two, gives the combination of the law is A is proportional to Q1 Q2 by R square. Okay. So this is the final statement of the law. That means I am getting the force, that expression of force is equals to some constant K into Q1 Q2 by R square. What is K? K is the proportionality constant. Okay. Now this is known the action reaction. What is that? So if I say there is two particles Q1 and Q2, on Q1, if I say this is the force acting, I say this is F12. What is 1, 2? 1, 2 means the force on 1 due to 2. On 1 due to 2. So 2 is offering the force. Similarly, F21 is in this direction. Okay, F21 is opposite direction. So F21 is what? Acting on the two particles, second particle by 1. Okay. So magnitude wise, F12 should be equal to F2. Magnitude wise. But direction is opposite. Direction is opposite. So that's why these two forces are known as the action-reaction pair. Action-reaction pair means it obeys the Newton's third law. Newton's third law says that whenever there is a force of action, there must be force of reaction. So if I say F21 is there, so there must be F1. Okay. Only F12 cannot exist, or only F21 cannot exist. So these two exist simultaneously. Okay. Now, so when the distance between the two charged particles is half, the force between them becomes half. So initially, let us say this is the charged particle Q1 and Q2. Okay. And the separation is R. So initially force is how much? Force is equal to K Q1 Q2 by R square. Okay. Now the distance become half. That means this distance become R by 2. Charge remains same. Q1 Q2 charge remains same. So force F prime becomes K times Q1 Q2 divided by R square by 4. Okay. That is what you can say 4 times F. So that is it becomes 4 times. So what you can conclude that if the distance of separation between the charged particle is reduced, then the force is increased. Why? Because it is inverse proportional to the square of the distance.
Yes.
Now let us say each of the 2-point particle charge are doubled. That means if the charge is Q and Q1 and Q2, let us say, separation is R. So we know that force is equals to K times Q1 Q2 by R square. In the second situation, the charged particles are 2Q1 and 2Q. Charged particle double. And the distance is half. So R becomes R by 2. R becomes R by 2. Now the force F prime becomes how much? K times Q1 is 2Q1. Q2 is 2Q2. Divided by R square means R by 2 whole square. So ultimately what I am getting 16 times K Q1 Q2 by R square. That means it is 16 times more than the first one. Okay. So force of interaction becomes n times. What is that n number? N is 16 times. Okay. So if I increase the charge as well as reduce the distance between them, then overall both effects are basically increasing the force. So force is increased. Now this is the final format of the Coulomb's law. F is equals to K times Q1 Q2 by R square. What is K? K is the proportionality constant. If I want to calculate the value of K, so from experiment I can obtain the value of K. Now what is the K value? K is 9 into 10 to the 1 9. Okay, this is the K value. Now regarding the unit, what is the unit? If I write the expression of the K should be equal to how much? F into R square divided by Q1 Q2. Okay, so F is in Newton unit in SI system, R is in meter square, divided by Coulomb square, because Q1, Q2 both are in Coulomb, so Coulomb square. So what is the unit for K? K is basically Newton meter square by Coulomb square. Okay, so K is called the proportionality constant, or it is known as the Coulomb's constant. Known as the Coulomb's constant. So there are two similar and equal charges repel each other with a force of 1.6 Newton when they are placed at 3 meter apart. Strength of each charge. So let us say two charges are same charge Q. They are repelling each other when the distance R is equal to 3 meter. Okay, and the force of repulsion is given as 1.6 Newton. So I know that F is equals to K times Q1 Q2 by R square. This is the formula. Now both are equal charges. So can I write K times Q square by R square? Okay. So Q square becomes how much? F into R square by K. Now put the value is 1.6. If R is 3 square means 9 and K is how much? 9 into 1 9. Okay, that means it becomes 1.6 into 10 to the 1 minus 9. Now make it 16 into 10 to the 1 minus 10. Okay, so Q square becomes 16 into 10 to the 1 minus 10. So Q becomes how much? So that means Q becomes 4 into 10 to the power minus 5. Now make it 40 into 10 to the minus 6. So 40 into the minus 6 Coulomb. That means 40 microcoulomb. Okay. So charge of strength of each charge is 40 micro. Okay. So K is basically Coulomb's constant, and that Coulomb's constant is found by experiment. Okay. Now similar to the Coulombic force, the Fe electrostatic force, there is another force, the gravitational force. Gravitational force. So Fg represents the gravitational force, Fe represents the electrostatic force between the two electrons situated at some distance. Now you are asked to calculate the ratio of Fg to F. Okay, let us say this is the one electron, this is another electron. The gap between them is R. Now between these two electrons there is electrostatic force of repulsion. So if I say this is Fe force, electrostatic repulsion. Similarly, between these two particles, the force of attraction of gravity is there, Fg. Okay, you are asked to calculate the ratio of Fg and F. Now I know that Fe is equal to how much? Fe should be equal to K times Q1 Q2 by R square. That is K times E square by R square. Nah. And I know the expression for the Fg, that the gravitation value is capital G times M1 M2 by R square. So electron has mass. Electron has mass. So that means it should be equal G times M square by R square. Now in the question you are asked to calculate the ratio of Fg by F. Fg by F. And what is Fg? Fg is capital G M square by R square. and it is your k e square by r square. So ultimately r square cancels out. So I am left with g m square by a into e square. Now put all the value. Now what is g? G is called the gravitational constant, universal gravitational constant. Its value is 6.67 in 10 to the power minus 8. Okay. And what is mass? Mass is the mass of electron. Electronic mass is 9.1 in 10 to the power minus 31 whole square. Okay. Divided by k. K is Coulomb constant, so 9 into 1 9. What is E? E is the electronic charge, that is 1.6 into 1 minus 19 whole square. Okay. So first try to adjust the, forget about the constant part. Some constant part will come. Adjust the 10 to the power. So what is the 10 to the power number? Initially it is minus 11. Then from here it becomes minus 62. In the denominator 10 to the minus 19 comes in the numerator. So plus 28. Yeah, 38. 1938. Then 9 becomes minus 9. Okay. So it becomes how much? Minus 44. No? 10 to the minus 44. So something in your minus 44. Now come to the something part. Now what is something number written? It is 6.67. 9.1 whole square. So here 1 9 and the denominator another 9 will cancel out. So ultimately I am left with only 9. So 6.67. 6.67 into 9 divided by 1.6 whole square. This much number. So 6.67 into 9 divided by 1.6, that number is more than 10. 6.679, almost 6.679 in almost 60 divided by 1.6 whole square, that number is more than 10. So that means it should be 110 will come inside, outside. Okay. So ultimately I am getting something in 10 to the power minus 43. So this is called the order. So you are asked to calculate this order, that is 10 to the minus 43. So what you understand from this exercise is that the force of attraction of gravity is very, very less compared to the electrostatic attraction of repulsive force. Why? That means Fg number is, Fe number is much, much greater than Fg. Can I conclude that? But this Fg, that is the force of gravity, is only dominant in case of heavenly bodies. That means if I consider the force of attraction between the earth and moon, or earth and sun, or any planet with the sun, that force is very large. Why? Because for those particles, mass is quite higher side. Okay. So Fg is a number which determines the force of gravity, and that force of gravity is dominant whenever the mass is on the higher side. But electric force or the electrostatic force of attraction or repulsion is always on the higher side. Always on the higher side, because the K parameter that is there inside this electric force is on the higher side. K number is 9 10 to the 9. Corresponding to capital G number is very less. Okay. Capital G number is very less. Now, there are two charges, both are same, 1 microcoulomb and 5 microcoulomb. The ratio of force on them. That means if I see the plus 1 microcoulomb charge is there, another charge is plus 5 microcoulomb charge is there. So on one particle, if I say F12 is acting, on the other particle F21 is acting. Okay. So nature wise, these two forces are repulsive force, because this is the force of repulsion between the two same charged particles. Both are positive, but magnitude wise they will be equal. We are asked to calculate the ratio of force. So it should be 1:1. Why? Because force is equal. F12 is equal to F21. Okay. So ratio is 1:1. Now, this is the final conclusion, that K is known as the Coulomb constant. Why? Because invented by the Coulomb. Coulomb was the first one to propose this expression. So that's why K is known as the Coulomb's constant, and K can be measured experimentally. So Coulomb does the experiment to measure the value of K, and the exact value of K is this much. It is the exact number. But we don't consider this number, we only consider K as 9 into 10 to the 9. Now regarding the unit, so K has a unit of what? Newton meter square per Coulomb square. Okay. Newton meter square per Coulomb square is the unit of K. Okay. Now, Now consider another concept that is called the, if I say this is the expression of force, now K can also be replaced by this number, 1 by 4 pi epsilon. Everything remains same, na? So K is replaced by the number 1 by 4 pi epsilon naught. This is called the epsilon. Called the epsilon. What is epsilon? Epsilon is called the permittivity of free space. What is free space? Free space means that or air. Okay, or air. Okay, so what is epsilon naught? Epsilon naught is equal to, can I write that is equal to 1 by 4 pi k. Okay, that is 1 by 4 pi into 9 into 1 9. Nah. So once I simplify this number, that number comes to be as 8.85 into 21 minus 2. Okay, and regarding the unit, it is the reverse of the reciprocal of the k number because k is coming in the denominator. So unit for epsilon should be reciprocal of k. So k has unit of what? K has unit of Newton meter square by Coulomb square. So epsilon has the unit of Coulomb square in the numerator divided by Newton into meter square. Okay.
Yes.
Now what is epsilon? Epsilon is known to be the permittivity. And what is permittivity? So permittivity is nothing but the how well the medium allows or permits electric field to pass through. Okay. So we know that whenever there is a charged particle, so it will create electric field. Now, charged particle is at rest, it will create the electric field. Whenever the charged particle, let us say is a Q charge, it will produce an electric field surrounding it. Now the electric field has to propagate through this medium. Let us say this is the air medium. Now how fast the electric field is propagating from one point to the other point? That defines the value. Okay. So epsilon naught is the permittivity of the free space. So it's nothing but the speed or how well the medium is allowing the electric field to propagate. Some medium will allow less, some medium will allow more. Okay. So the property of the medium. So value of epsilon is given as 8.85 divided by minus 12. Coulomb square in the numerator divided by Newton into meter square. Okay. Now come to the concept of electric. So far we discussed about the force experienced by the charged particle. Okay, I know what is the force. Now once I understand the force concept, Coulomb force, now we come to electric. So it is a region around the charged particle into which, when another charge is brought in, it experiences an electrostatic. What is the meaning of that? Meaning is, let us say there is a Q charge is there. Okay, Q charge is placed. So I know that if the charged particle is at rest, it will produce the electric field. So let us say I recognize a particular region, imaginary region. This is the region inside which it will create a field. What is that? How to explain that? So for that, if I place another charge particle, let us say I put a charge particle Q naught, which is outside this region. So now this Q and Q naught will not repel each other. Okay. So it will not experience any kind of force. So once I move this Q naught and ultimately go inside this region, now the Q naught will repel the force. Okay, now this force will come. So it is a region around a charged particle. So this is a region around a charged particle into which when another charge is brought in. So when I move the Q naught charge inside this region, then only the Q naught will feel a force. Otherwise it will not experience. Okay. So that means initially the Q will produce a electric field around. Initially the Q will produce electric field around the charge itself. And inside that field region, once I bring another charge, then we will feel the force. Okay. So it is a two-step process. It is a two-step process. So electrostatic interaction between the charge particle is a two-step process. Why? Because first process is the charge creates the electric field. Okay. And once I bring another charge inside that region, then only the force will come. So charge will create the field and field will create the force. Okay. But initially I learn about the force. Next we learn about the field. Why? Because it is easier to understand. So first we discuss about the force. Now we want to discuss about the field. The field is an imaginary region inside which a second particle when brought in will feel a force. Okay. Now, so this has to be measured. It has to be measured what is the amount of. So intensity of electric field, it's called the intensity of electric field. So what is the intensity of electric field? Intensity of electric field at a point is equals to the electrostatic force experienced by a unit positive charge. Okay, what is the meaning?
Yes.
Meaning is that let us say you have a charge Q over here, and once I bring a unit positive charge, +1 charge, so +1 Coulomb charge. So what is the force experienced by this +1 Coulomb charge? That is nothing but the intensity of electric. Okay, so let us say this is a Q charge at a distance of r. We brought one +1 Coulomb charge over here. So on this +1 Coulomb charge, what is the force of repulsion? That is equals to K Q into 1 divided by r square. That means it is equals to KQ by r square. Now there is a force on the +1 Coulomb charge. Now if I say this +1 Coulomb charge is resting at point A, then this force is nothing but called the electric field at point. That is equals to KQ by r square. Okay. So electric field has to be defined for a point. At a point. At a point means at, let us say, at point A. So what is the value of electric field? That is electric field is equals to KQ by r square. Okay. So this is the method by which I can calculate what is the amount of electric field at any particular point. Mathematically, I can get it in another way. Let us say you have a charge of Q over here, and there is another charge Q naught at point A. At point A, there is another charge. Let us say the separation between them is, let us say R. Now, first we calculate what is the force experienced by this Q naught charge. So this force is equal to K Q into Q naught by R square. Okay. So once I calculate this force, now I want to calculate what is the force per unit charge. That means I want what is the value of F by Q naught. Force per unit charge. What is that number? That number is KQ by R square. Okay. So that number is nothing but electric field at point. Okay. So electric field at point A has to be calculated based on the formula that is F divided by Q. So at any point, if you know the value of force, then divide by the charge. So that gives the value of electric field. So I know the force having a unit of Newton and Q having a unit of Coulomb. So Newton per Coulomb is the unit for field. Now it is a vector quantity. Why vector quantity? Because it has direction. Okay, it has direction. Let us say I take a negative charge, -2 charge, and here I took a +1 Coulomb charge. What is the force experienced by the +1 Coulomb? Now it is attractive force. So along this direction, the electric field will act. EA at point will be in this direction. If I take this as a positive charge, and if I say this is the point A, here I am taking +1 Coulomb. Now the force will be repulsive force, so electric field will be in the opposite direction. Okay. So electric field has a direction sense. For the positive charge, it should be away from the charge, because the arrow is away from the charge. At the charge, arrow is outward. But for the negative charge, it is toward the charge. Toward the charge. So direction is deeper. So electric field is a vector quantity. It has the direction and unit is Newton per Coulomb. So once I know the value of electric field, in other way, if I know the value of electric field at any particular point, how to calculate the force? Force can be calculated by based on E into Q naught number. Okay. E into Q naught. So electric field multiplied by charge will give the force. Let us say there is a force of 2.25 Newton acts on a charge of this thing. Calculate the intensity of electric field. So electric field is basically electric field at a particular point is equal to F by Q naught. Yes. Okay. So F is what? F is given as 2.25 Newton divided by 15 into the -2. That means 2.25 into the 4 divided by 15. That means 0.15. 15 into 15 means 2.25. So 1.5. 15 into 1.5. So 1.5 into 10 to the power 4. That is electric field. Then Newton per Coulomb. That means 15000. Yes. Okay, Newton per Coulomb. Now, an alpha particle is there. It is situated at an electric field of strength of this much. Force acting on it. So I know that alpha particle charge Q naught for the alpha particle is 2 times of E. 2 times of E. So 2 into 1.6 into 10 to the minus 19. This is the charge on the alpha particle. So what is the force? So force should be equals to E into Q. Na? E into Q. What is E? E is 15 into the power 4. Multiplied by 2 into 1.6 into 19. Okay. So 2 into 1.6 is 3.2. 3.2 into 15 into 10 to the power minus 15. So this is how much? 48. 48 into the minus 15. Okay. 48 into the minus 15 means 4.8 into the minus 14. So this one. This is. Okay. So 4.8 into 10 to the minus 4 Newton. Okay. So you can clearly see that electric field has a very large value. Okay. Na? Electric field has a value of 10 to the power 4. But what is the force that you are getting? That is small quantity. Why? Because the charge is on the smaller side. Na? So charge is on the smaller side. That makes the force to be on the lower side. But electric field is always on the higher side. Electric field number is always on the higher side. Okay.